Hello everyone. In this video we're going to be evaluating an infinite sum. We have 1 minus 1/2 plus 1/3 plus 1/4, minus 1/4 plus 1/5, so on and so forth. So we have the sum of the reciprocals and the signs alternate. So we're going to evaluate the sum using some techniques. But here's a quick question. What would happen if all the signs were plus signs, like 1 plus 1/2 plus 1/3 plus 1/4 plus 1/5, so on and so forth? I just want you to think about it and maybe explore a little bit and see if we can evaluate this sum as well. All right, I'm not going to answer this question, but we can kind of talk about it in the comment section. So how do you evaluate the first sum? So here's what we're going to do. First of all, we're going to define a function, and then we're going to differentiate it. So we're going to use derivatives. And then we're going to use geometric sequences, some interesting formulas, and then we're going to reverse the process. So that's going to be an interesting journey. Let's get started. So I'm going to define f of x as x minus 1/2 of x squared plus 1/3 of x cubed minus 1/4 of x to the 4th plus 1/5 x to the 5th, so on and so forth. So I can basically define this as 1 over x or 1 over k times x to the power k. And then multiply that by -1 to the power k plus 1 so that the signs can alternate. Make sense? We could also use this, we could write this using sigma, in other words. But anyways, so we're going to go ahead and define this function, and then we're going to differentiate it, and then we're going to go with that. But before we get into the differentiation part, let me go ahead and show you what this sum is going to look like. And then we're going to explain how that goes. So according to Wolfram Alpha, which is a really cool tool if you are studying math, it's going to do a lot of work for you. This sum, as I told you earlier, we can use sigma to write this, is equal to ln 2, but unfortunately Wolfram Alpha writes this as log, and that's approximately 0.69315. So if you go ahead and add a couple terms, you're going to notice that you're going to approach that value little by little. So let's go ahead and explore how this goes. So we're trying to evaluate 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5, so on and so forth. And then I'm going to go off of the function f of x, as f of x is defined as x minus 1/2 of x squared plus 1/3 of x cubed minus 1/4 of x to the 4th plus 1/5, so on and so forth. Okay, go. So notice that using this function will be helpful in evaluating the sum, because if I can find the value of f of x, then I can just plug in x equals 1, because the value, the sum that I'm trying to evaluate, is actually equivalent to f of 1 if this function is well defined. Anyways, let's go ahead and work on this function. Like I said earlier, we're going to differentiate and then go backwards. So let's differentiate this using rules. The derivative of x is 1. The derivative of 1/2 x squared is 1/2 times 2x. And then this is 1/3 times 3x squared. And then this is, that should be a minus sign, minus 1/4 times 4x cubed, so on and so forth. So we use the properties of powers to differentiate. And then you can simplify this a little bit. It's going to give you something much nicer than this. And it's going to be the following. 1 minus, now 2 cancels out, 3 cancels out, 4 cancels out. Pretty much all the coefficients cancel out, leaving us with 1 or -1. And this is going to look like 1 minus x plus x squared minus x cubed plus x to the 4th power minus x to the 5th power plus ... You get the idea, right? This is the derivative of f, remember. Our goal is to find f of 1 at the end. Okay? So how do you evaluate this sum? First of all, just suppose that x is between -1 and 1. In that case, we would get the following. You would get an infinite geometric series, right? And this could definitely be written as follows. We can write this as 1 plus x squared plus x to the 4th plus x to the 6th ... And then from this, just subtract the terms that have an odd power, like x, x cubed, and then x to the 5th, so on and so forth. Great. So this is f prime of x, and let's see if we can evaluate this using the formula for geometric series, the infinite one. So how does that formula work? If you remember, the formula for 1 plus r squared dot 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 is equal to 1 over 1 minus r. If the first term is 1 and the common ratio is r, then this is equivalent to 1 over 1 minus r. But in this case, the common ratio is not r or x, it is x squared. Because if you look at this, this is x squared to the first power, this is x squared squared, this is x squared cubed, so on and so forth. So the first part of this, which is this part right here, is going to be equal to 1 over 1 minus x squared. Awesome. What about the second part? The second part can be written as follows. I can take out a minus x, and inside I'm going to get 1 plus x squared plus x to the fourth, so on and so forth. And guess what? It's the exact same thing. So this is going to be minus x times 1 over 1 minus x squared. Isn't that awesome? We got actually a closed expression for f prime of x, which is really, really, really cool. Okay, so let's go ahead and see what we can do with that. But first, simplify. How do you simplify this? This is 1 over 1 minus x squared minus x over 1 minus x squared. We already have a common denominator, so I can just write it as 1 minus x divided by 1 minus x squared. But 1 minus x squared can be factored out as 1 plus x, 1 minus x. And then if x does not equal 1, obviously you don't want x to be 1, because then you're going to get something like 1 minus 1 plus 1 minus 1. It's kind of like an interesting series that actually doesn't converge. Okay, because it depends on how you're looking at it. You can get any value you want pretty much. And I think Mathologer made a video about it. If I can find the link, I'll share with you. Anyways, 1 over 1 plus x. So that's the derivative of f or f prime, just f prime. And that's really cool, because now notice that we got a really nice simplified expression. And remember, I told you we were going to reverse the process. So our goal is to find f of 1, but first let's find f of x. And you can find f of x by integrating f prime. But of course, when you integrate f prime, you're going to get a constant, but that's fine. So let's go ahead and do this. Let's integrate this expression right here first. What am I integrating? I'm integrating 1 over 1 plus x dx. And as you know, this is equivalent to ln absolute value of 1 plus x plus c, c being a constant. So how am I going to evaluate the constant, right? So here's what I'm going to do. To figure out what the constant is, I am going to replace x with 0. Remember, f of x was defined as follows: x minus 1/2 x squared plus 1/3 x cubed minus 1/4 x to the fourth power plus dot dot dot. Now, if you replace x with 0, since we only have powers of x, f of 0 is going to be 0. Awesome. Let's go ahead and plug it in here. By the way, this is f of x. So f of 0 is going to be from here, ln 1 plus 0, which is ln 1 plus c. But ln 1 is 0, so it's just going to be c. But we do know that f of 0 is 0, so c is equal to 0. So hopefully you see what I see. If c is equal to 0 and f of x is ln absolute value of 1 plus x plus c, then f of x is going to be ln 1 plus x. The absolute value, we don't need it, but let's just keep it there for now. Now remember, to evaluate our expression, I was supposed to replace x with 1 in f of x. In other words, this is equal to f of 1. And f of 1 from here is ln 1 plus 1, which is ln 2. So this sum is actually equal to, or it converges to, ln 2. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe. Take care. Actually, not tomorrow. It's actually in 12 hours. See you in 12 hours for the premiere. Take care. Bye-bye.